I'm hearing a whole bunch of jibber jabber, and I am hopeful that here, this is what we're working on. I'm hopeful that all your jibber jabber is productive math stuff. So we got calculators that'll, is that running?
Yeah.
We have calculators that will do all the math for us. What we need to figure out though, when we look at a problem is this going to be a P problem or a C problem? That's a big deal, all right? So, Jake must choose 4 teammates to shoot around. There are 10 men on the team, and he's going to pick 4 of them. All right. Is that going to be 10 P4 or 10 C4? C4. Because this is just random guys shooting around. So 10 C4 is your answer. All right? So type it in and tell me what you get. What's 10 C4? What is it? 210. Everybody good with that? Kamara is going to assign the following roles on CHS Live: anchor, sportscaster, and jokester. There are 12 students eligible. So this is going to be 12 P3 or 12 C3. Why is it P? It is P. Why is it P? Order matters. The jobs are different. You guys, do you see that in Jake's problem, everybody's doing the same thing? They're all standing out there shooting baskets. In Kamara's problem, everybody's doing something different. And when that happens, order matters. So what is that one? 1320. So the answer is this. This is the answer. This is the setup. That's good. But this is the answer. Make sure you're typing it in. Kara must tell Coach White that she cannot play in 4 of the 21 games this season. Is it 21 P4 or 21 C4? C. There's 4 games she's not playing in. We don't know which games they are. Doesn't matter. But she just says, I can't handle it. I'm going to sit out 4 games. So 21 C4. And what is that? 21 C4 is 5,985. Okay, I know Beatrice isn't here to ask. She got a ton of siblings. I just guessed 7. Beatrice is going to take 2 of her 7 siblings to the movie. 7 C2, 7 P2. C. They're going to the movie. Doesn't matter if she asks Susie first or Billy first. They're going to the movie. 7 C2, which is 21. And I forgot how many sisters you have, so I said 4. Meg is going to give her 4 sisters her favorite math possessions. Meg is going to give her 4 sisters calculator, pencil, binder, and marker. Is it 4 P4 or 4 C4?
4 P4.
4 P4. That should be, what is 4 P4? 24. All right, everybody okay with that? Why is Meg's problem a P? Because the presents are different, right? The presents are different. Man, we got everybody late today. Okay. Next, evaluate this by hand. All right? Gotta know a formula. It says evaluate by hand. I know you can type in on your calculator 22C20. That's not what I'm looking for. I want to see a formula. What is the formula for 22C20, Dan?
Is it N with the N minus R?
Okay, so the thing is the factorial symbol, okay? But he says in general, this is the general formula. It's n factorial over n minus r factorial, r factorial. That's the combination general formula. The permutation general formula is exactly the same, but it doesn't have this. Okay? So, applying this specific problem to that general formula, what's in the numerator? 22 factorial. What's in the denominator? 2 factorial, 20 factorial. Now, we're still not using our calculator. We do not need a calculator. Because what is 22 factorial? 22, 21, 20, da 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 da.
So it's just 22 times 21.
And 20 factorial is this right here. So those are going to cancel. I still have a 2 in the bottom, a 2 times 1, a 2 in the bottom. So basically, your answer is going to be 11 times 21. Right?
Yeah. Wait, 11.
So 11 times 21 is 231. So just for fun, do 22C20 on your calculator and see if you get 231. Amazing. I have 8 flavors of cake and 10 flavors of icing. How many different graduation cakes can I make? Okay, so pretend I have a big pantry. I don't, but pretend I do. I'm gonna make your graduation cake. I go to my pantry and I have to choose a cake type, flavor, and I have to pick an icing flavor. That's it, I'm making 2 cakes. How many choices do I have for cake? 8. How many choices do I have for frosting? How many choices do I have altogether? 8. It's easy. This is like the jumper shirt problem. Go to my closet, pick a jumper, pick a shirt. Same thing, pick a cake, pick a frosting. How many ways can I arrange the letters? You are my favorite, so my.
17 letters.
All right, what's the first thing I need to do? Count them up.
There's 17.
You already did that?
Yeah.
I hope you're right, 17. Counts up the letters and he says there's 17. What's the next thing I have to figure out? Do I have any repeats?
Yes.
It looks like I have, I'm gonna just pull them out. Looks like I have 2 O's.
2 O's, 2 I's, and 2 E's.
And I have 2 A's. I have 2 E's. Do I have anything else?
2 R's.
2 R's. Oh, I have 2 Y's. Is that it? Okay, now, remember, these all happen to be 2's, but remember, you could have 3 of a letter, and that would be 3 factorial. Here's the good news about 2 factorial. What is 2 factorial? 2. So basically, your denominator is 2 times 2 times 2 times 2 times 2. So you could save some time typing in if you did 17 factorial divided by 32. Now guys, don't try that with any other number. It works with 2, because 2 factorial is 2. So, what is it? 17 factorial divided by 32 is pretty big.
Got 1.1 to the 10.
Oh gosh, it goes
times
into
10 to
scientific
13.
notation.
Yeah.
Yep, 1.1115 times 10 to the, oh my gosh, 13, huge. All right, find the third term of 2x minus y to the 5th.
Oh, yeah.
All right, so I think this is, we did this last time or the time before. This is where we have our answer. If we did the whole thing, it would be a great big long thing. How did we start that? What was our process for that?
Yeah,
Yeah, Max?
Like the x's and y's need to add up as to 5.
So every term, including, I want the third one, every term is gonna have a power of 2x and a power of negative y. These two things are going to be the variable components of the problem. These exponents, eventually I have to put exponents on here, and they're gonna have to add up to 5. Now, we recall, hopefully, that if we did the whole thing, the very first one, whatever the first term was, the power on the 2x would be 5, and then it would go down to 4, and then down to 3. Now that's kind of coincidence, but this is gonna be a 3, right? The third term is gonna be a 3, because I started with 5. 5, 4, 3. If I started with 6, it wouldn't be a 3, it'd be a 4. Right, so count down. And then, to Max's point, if that's a 3, this is gonna be a 2. Okay, you're not done, there's something missing. What else needs to be in the problem? A coefficient. And where do I get those? I got a couple choices. I could get them, and since this is only to the 5th, that wouldn't be bad. I could get it from Pascal's triangle. So remember how that works, 1, 1, and then 1 on each end, adding in the middle. So I could definitely, since it's only to the 5th power, I could use Pascal's triangle, and there is the coefficient for the third one. I'm gonna put a 10 out here. Now, what is my other choice? For example, if this had been a 50, I don't think I'd want to do this. I use combinations. So remember, in the 5th row, this is 5C5. And then they count down just like the exponents do. 5C4, 5C3. So another option for you, if you didn't want to write out the triangle, you could count down your combination numbers. 5C5, 5C4, 5C3 is the third one. If you type that on your calculator, it's 10. All right, now we simplify, remembering that the exponent goes with the whole shebang. So this is not a 2, this is 8. This is not a -1, it's -1 squared, which is 1. So we have 80 x cubed y squared is the third term of that. Okay? And then finally, to get back to the whole combination thing, what is the 4th number in the 17th row of Pascal's triangle? Well, what's the first number in the 17th row? Well, yeah, but it's 17C17, that is 1.
17C4.
And then 17C6 16 would be the second number, right? And then 17C15 is the third number, and I want the fourth one. So the fourth one is gonna be 17C14. Did you get 680? As the fourth number in the 17th row. Tomorrow, peeps, we're gonna have a little quizzy poo. I don't know how many questions it's gonna have, but it's gonna be this kind of questions, all right? So however many questions, we have a short period tomorrow, however many questions I put together, it's gonna be like these. Everybody clear on that? All right. Now, let's get back to our notes. I think we have a tiny bit to finish up there. All right, so yesterday, we started problem number 4. And we did A and B already. Let's just do a quick recap. What is the probability of getting exactly 1, 3, and we're rolling it 5 times? What did we start with? 5C1, right? Why did we start that way? Because we have 5 rolls, and we're picking one of them to give us a 3, and we don't care which one it is. So we said 5C1. And then we multiplied that by 2 things. What are we trying to do? Get a 3. So this is the probability of getting a 3, and this is the probability of not a 3. When I roll a die, I either get a 3 or I don't get a 3. The probability I get a 3 is 1/6. The probability I don't get a 3 then is 5/6. And in this particular problem, I want 1 3 and 4 not 3s. That's the answer to the question. Okay? Now, look at numbers or letter C. What is the probability? Same thing, rolling 5 times, but I want no more than 1 4. Okay, now wait a second. What does that mean? I could get 1 4, or I could get no 4s. So this is like 2 problems in one. I could get no 4s, or I could get 1 4. Now, won't the 1 4 case look just like this?
Where'd those exponents come from? 1 and 4? Sorry.
5 rules, 1 3, the other 4 are not 3s. 5 rules. Now, this one is gonna look just like this one. I'm gonna roll the die 5 times, and one of them is gonna be what I want. And the other ones are gonna be what I don't want. So that is exactly the same as this, because the probability of getting a 4 is the same as the probability of getting a 3. Now, what does this look like? No 4s. Well, now it's 5C0 and 1/6 to the 0 and 5/6 to the 5th. So you are rolling the die 5 times. We want none of them to be 4s. So here's the probability of a 4. I don't want any of those. Technically, you don't even need to write this down, because what is this? That's just 1. So if it's 0 of something, you don't really need to even write it down. I did so that they look the same. And then what am I gonna do with these two answers? I'm gonna type this in, I'm gonna type this in. What am I gonna do with them since it's this or this?
Do you add them or?
I add them. Add them. Don't I want the total probability?
Yes.
When it's an or, you add. When it's an and, you multiply. That's why these are multiplied. I want 1 4 and I want 4 other things. That's a multiply. All right, let's type that in, make sure we can.
It's like 0.80.
Okay, hang on,
Okay.
I gotta catch up. What did you say you got?
I got 2.4.
Okay, let's stop right there. Can the answer be 2.4? Why not? Probability can't be more than 1. So if we're doing a probability question, we can't be more than 1. So I don't know that I'm right, but I know it's not 2. Point whatever. I got 0.8037.
Yeah.
Okay, good. That seemed awfully high to me, but 0.8038 if I round it off to 4 decimal places. So let me try something. I'm gonna math frac that. Oh yeah, I could have written it as a fraction. That doesn't always work with these probabilities, but it did that time. All right, we're gonna do one more. Okay, then we're gonna lunch. All right, and we'll finish up the back part with lunch. Okay, same thing. I'm rolling the die 5 times. This time I want to get at least 1 6. All right, so stop and think a minute. What does at least 1 6 mean?
1 or more.
That means 1 6 or 2 6s or, oh my
4
goodness.
or 5 or 6.
I'm only rolling 5 times,
Oh,
aren't I?
yeah.
So I'm gonna stop there. Now, I want you to listen carefully. Just think. First of all, could we do all these individually? We absolutely could. For example, what would 4 6s look like? 5C4, 5 rolls, pick 4 of them. The probability of a 6 is 1 6, then the probability of not a 6 is 5 6. That would be the probability of getting exactly 4 6s. Would you agree with that? I could do the same thing here, and here, and here, and here, and then what would I do with all those answers? Add them up, and that would be the answer. That will always work. That is the answer. However, it is a lot of times easier to go through the back door. Here's what I mean. If you think about, you have to get at least 1 6. What is the only thing you don't want to have happen? Getting no 6s? So what if we found the probability of no 6s and subtracted that from 1? Does that make sense to you? The only possibilities are you get 5, 4, 3, 2, 1, or none. That's it. So if you want all of that, isn't that going to be 100% minus this? So this one's easy. What would no 6s look like? 5C0, 1 6 to the 0th, and 5 6 to the 5th. We're rolling 5 times. So I want 5 numbers that aren't 6s. So now,
Go to 60 something, I think, or 0.6.
yeah, did you get 598? Yeah. So about a 60% chance. I wonder if that math fracks. It does. So 4651 over 776. Now, if we did each of these individually and added them up, that is exactly what we would get. But it's a lot shorter, less work to do it this way. So moral of the story, then we'll let you go. Moral of the story is, you can either add up the probabilities of all the things that you want, or you can do 1 minus the probabilities of the things you don't want. Okay? Max is ready. He's just waiting for that 30 gun to go off. All right, I want you back at 30. Or no, 47. Back at 47.
You said 48, okay.
I think I said 47.